And even in Sweden, there are 3 different systems that we use, so they're incompatible with each other. And Europe is even worse, there are even more, so even more incompatibility. And also, unfortunately, in Sweden, all of them are proprietary, and also doesn't work on all, for example, 64-bit platforms. And okay, yes. This okay, so we have 3 different EI systems in Sweden. Fribid, which is a free software project that I'm involved in. It implements the time-guided system and solves this problem as well. Okay, so this is this list is also not exhaustive. There is much more. There are much more systems in Europe, and many of them are proprietary. We have a lot of work to do, we could say. Okay, time guiding, physical ID, you get a certificate. It can be a soft token, and it can also be a smart card. This is unlike most other systems. Most people don't use soft tokens for electronic ID, but I think we even know that actually. There's also some work to use cell phones for authentication. We use a SIM card can work as a key store. Okay, so fribid as the official software is proprietary. Fribid is reverse engineered. It's been 1 year since the public release, so it's quite unstable and alpha. Most features are there, but something like, for example, enrollment is not implemented yet. We have the soft tokens and smart cards. And smart cards is what is done through an SC, but you can actually use anything at EPC level. Technical information. Fribid, you can even see that's nothing really special about that. We used the security library, crypto library. We used OpenSSL. In the beginning, we used NSS actually, but we found that was too centric. It had a database-oriented model where it's hard to use tokens that are separate from the database. For example, they are on a file or on a USB stick or something. So we decided to go for OpenSSL instead. Of course, OpenSC for smart card support works pretty well. We also used Fribid. It's a browser plugin. We use the Netscape plugin API. It's a really old API from Netscape time. It works in pretty much all browsers except Internet Explorer. So, because the signature, the way you get a signature from the time-guided software, it's really simple. You send here. You send a nonce value and some text you want to be signed to the plugin, and then you call a function on it, and first you get a confirmation window where you can see the message you want to sign, and you can also say a password, you can select your token to use, and so on. So when this is done, you get an XML signature. Data here, status going through. And also you have some extra information here about the domain name and IP address, which is probably there to enter. IP address and domain name probably to prevent managed label and looking attack, phishing, and so on, and on security. Otherwise, it's a typical XML signature, certificate chain, and biggest signature. Okay. And the protocol is a bit more complicated. It's also not that hard. Also based on standards. Recipient's name, PKCS 10 and 7, certificates of standard formats, but the protocol itself is not standardized. They use some extensions to these protocols. They are not true standards, and that has made it slightly harder to implement in OpenSSL and so on. Also need to create ASN. It is quite technical, but we needed to create ASN one objects and so on for special data structures. Okay. So there are a few difficulties. Of course, it's a secret protocol. We reverse engineered, of course. It still uses a lot of standards. XML, DSIG, BTT standard, or usual stuff like this1, PKCS7 and so on. And one problem here is that the server-side software is not publicity available. So testing your software, and there are also, to make it even harder, there are also different implementations. So you better be completely generating completely the same output, make everything 100% compatible. Also, of course, as we do with legally binding signatures, the only way to test things is to actually sign things. That makes debugging and testing a bit harder. Because sometimes, okay, there was a bug on a page when you register a new business, and okay, that's obviously something that's hard to like test yourself, because when you need to register a business, it's difficult to. Okay.
How many businesses do you have now?
Yeah. And we also, there was also, as I told you, we use MSS initially.
Sorry, I don't know if I should be interrupting you, but we say secret protocol. Who controls that protocol?
So this is it's like a corporation of the Swedish banks. They have formed an organization that owns created their own.
But they won't tell you.
So
Even if you sign an NDA?
I don't know.
No.
I don't think so.
They have their own client, so they want to control everything.
Oh dear.
Yeah. Another very minor annoyance. This protocol uses blocking JavaScript calls. That's designed in the protocol, and that means that when this sign dialog appears when you enter your PIN, your browser window is frozen. We have a real ugly hack for that, but this is something we really can't do anything about. So the future plugin developers don't use blocking calls. Okay. I'm going to speak some about browser security in general, browser security software in general, how we should make it, what we should think about, and so on. Also, we might not just want to use it for electronic identity, because there are many other places. I mean, the technology you use in the bottom is that's public key technology, generate signatures and so on, and that can of course be used for other things. For example, as an alternative to passwords, alternative to session IDs, which could prevent things like cookie stealing, stolen password databases. Of course, you don't have passwords, dictionary attacks, sniffing, etc. Of course, if this is just what you want, you can use TLS. If you just want authentication, you can use DNS, SSL, same thing. But then you don't get signatures. And why do you want signatures? Well, there was a reason probably you already knew, but for example, you may want to store the signature, you want to prove to someone, a third party, that this agreement has been made and so on. There's also the question of should you see what you're signing. So this is something that actually all EID protocols don't do, and I think all of them actually rely on the software in the computer, where the software displays the message, and that means that if the computer gets compromised, then it will change the message that is displayed. The user is frequent to see signing something else, and that is something that's really hard to do something about. But if you just display the message that user is signing, we can to at least prevent some kinds of attack, running middlemen and so on. Probably the use SSL in this case, but it's still additional security because you don't have build security holes in SSL implementations and so on. But one more thing that you need is timestamping. This is because the signatures they need to last for a very long time. Typically, it can be 10 years or so. It's typically mandated by some law somewhere. There are two. Okay, the timestamping means that you typically hash everything you have signed up, and it is secure timestamping. And this means that if the crypto algorithm behind the signature, if that is broken somehow some time later, then hash will prove that the signature was made when the crypto system was still not broken. This means that you can use crypto, you can rely on your signatures for a longer time. And there are two different approaches. One is more centralized one where you use a trusted third party. You can also use essentially publishing your hashes essentially, because it's in some place where you can verify that. Also another problem is not specific to signature generation. It's also a problem of itself. There's no standard for doing enrollment. Generating key pairs is not standardized at all. There are some vendor-specific approaches like key and tag in Firefox, and I think that Chrome has some JavaScript object or something that you can use to generate a key pair in the browser. It's mostly, or it's unstandardized. You have to use different approaches for each browser. This is something that each of the, or I think most of the EI systems have to do as well. Have their own solution too. You also have the question of how do you protect privacy. In some cases you might not want to reveal your identity, but you still want to be able to log into a website. For example, you book something and you want to be able to later unbook it. But in this case you of course don't want to use normal EID. And I don't know a good solution to this, but okay, if anyone knows any good solution, you can raise your hand or something. But a simple solution is just to generate different key pair each time. You have to use a soft token because the hard part typically don't allow for many different tokens. Of course, you will also want to build on to create some new standard. You would want to only implement a layer between the website and the TPCS11 interface. You don't want to deal with encrypted because you already have TPCS11. And that doesn't mean you can use soft tokens as well. Signature formats are unfortunately they are actually standardized. I think pretty much all of them, I'm not sure if all of them, most of the European EIDs use XRS. IC is an exception that use XLDC, but on the other hand, XLDC is a predecessor to XRS. Okay. So here are some different existing existing software and also some standards that are, or specifications that are in progress, but they don't have implementations yet. For example, we have different EIDs, fribid, SDID software. We also have the WASP project, which is it's not implemented yet. The implementation, there is a specification. I think it's Anders, do you have any comments? Anders, do you have any comments on the WASP?
On the WASP?
Yes.
It's something I started a few years ago. It's a suggestion for a signature in browser.
Okay. Another signature in browser specification. Also some, just for reference, that's Excel here. So there's also a project called DPG of, that's not education only, but that's DPG keys can be used for signing as well. You could extend it. And probably this list is not exhaustive, or I know it's not exhaustive. So I think we were actually finished before time. I don't know.
Very well.
That was good, okay. So I made a tiny URL link. This is a link to the fribid wiki. So with links to different standards and different projects and different related things. Okay. Okay, questions? Okay.